Hello, this video will act as a follow-on explainer for our first example video and should provide a good foundation going forward regarding how the SoftHub's rule engine interprets the rule sets we'll be presenting. We're going to again try to keep this video short, so we'll cut right to the chase and talk about the SoftHub's rule engine and how it works. The SoftHub rule engine is an object-based rule engine. There are currently 6 types of objects supported. To configure the SoftHub, the user defines a collection of objects which the SoftHub will instantiate. The user then creates the object rules themselves, which in turn dictate how the objects will interact. As you will see, the different object types are somewhat hierarchical and will often cross-reference each other. In particular, rule objects themselves are actually a structured set of references to other object types. Quickly, we'll run through the 6 object types and give some general examples of each. For most object types, there will be many subtypes available for the user to choose from when building their configuration files. The first object type we'll talk about are event objects. As events occur or are detected by the various components of the SoftHub, an event object is written to a global queue to be processed by the rule engine. As event objects are received by the rule engine, they may trigger one or more rule objects to be evaluated. Examples of event object subtypes include the SoftHub application starting up, a sensor successfully connecting or disconnecting, a new packet being received, or a timer expiring. State objects can be used to create complex Boolean logic statements to conditionally control the execution of individual rule objects. Each state object will check the Boolean state of some current system characteristic. Examples of state objects include the value of a flag variable, a sensor data value relative to some threshold, the value of a GPIO, or the current time of day. Action objects are as their name implies. Each action object will perform some specific individual task within the SoftHub. Examples of action objects include sending data to a remote server, starting a timer, enabling or disabling a GPIO, or initiating the connection process for a new sensor. Rule objects are at the heart of all SoftHub processing and are composed of references to the previous 3 object types we've just described. Each rule object will have exactly one event object reference. This is the event that will trigger the evaluation of the rule object itself. Next, a rule object may optionally reference one or more state objects. State objects may be standalone or may be combined by Boolean logic operators to create complex conditional logic. If present, the conditional state logic tells the rule engine to either continue processing the rule if the state logic is true, or to stop processing the rule and move on to any other rules waiting to be evaluated if the state logic is false. Lastly, each rule object will reference one or more action objects, which again will only be executed if any conditional logic has resolved to true. To summarize, rule objects can be thought of as when, if, do statements, which is to say, when the triggering event occurs, if any conditional state logic has been met, do each of the rule's action objects. It should also be noted that while each rule object may be triggered by only one event object, any event object may trigger one or more rule objects. That may be a little hard to follow now, but should become clearer as we move through some examples. There are 2 remaining object types. First, there are sensor stream objects, which provide information regarding the sensors the user may want to connect to. And second, there are user report objects, which allow the user to create custom-tailored data packets. These packets can be in either binary or XML format and can aggregate data from a variety of sources. For example, a custom packet may include one or more recent values from a connected sensor, sensor values averaged over time, a GPIO value, or a cache of historic sensor data values. Before we move on to the next example video, we'll quickly review the rule objects and hence the when, if, do logic for the first 2 examples in our demo series. Our first demo presented a scenario where we connected two sensors and then forwarded every packet from those sensors to a remote cloud server. Our rule set had only two rule objects. One effectively said, when a new ANT packet arrives, do a single action, which was to forward the most recently received ANT packet to our remote packet capture server. There was no conditional logic specified, so the optional if statement was omitted. The second rule object similarly said, when a new Bluetooth Low Energy packet arrives, again, do a single action, which was to forward the latest Bluetooth Low Energy packet to our remote packet capture server. Our second example is a variation of the first example and is meant to introduce two new object types, timer action objects and time of day state objects. In the second scenario, we're still connecting to the same two ANT and Bluetooth Low Energy sensors and forwarding packets to our remote packet capture server. However, instead of forwarding each packet as it arrives, we'll send the most recent packet received from each sensor only every 30 seconds. We'll also add some conditional state logic so packets are only sent between the hours of 9 a.m. and 5 p.m. Again, we require just two rule objects to configure the scenario. The first rule effectively says, when the system startup event occurs, do a single action which will start a continuous 30-second timer. The second rule says, when the timer expired event occurs, if it is after 9 a.m. and before 5 p.m., do the same two action objects from our previous example, one of which forwards the latest ANT packet and the other which forwards the latest Bluetooth Low Energy packet. In closing, we'll add that in practice, due to the hierarchical nature of rule objects, the rule objects themselves are typically the last objects to be defined. However, when sketching out the logic for a new SoftHub application, it is generally easiest to start with a set of when-if-do statements and then work backwards, filling in the supporting objects after the core logic has been defined. Again, we've tried to keep this video short, but for more in-depth information on the various object types and rule engine processing, please refer to the SoftHub Introduction and Configuration Manuals available from our website and linked below in the video description. And thanks again for watching.